Welcome, everyone. इस विश्लेषण में, we are going to unpack a truly fascinating natural mystery. I want you to start off by picturing this in your head. Imagine you're standing on top of a massive snow-covered mountain peak right at the crack of dawn. All around you, nothing but blinding white snow, piercingly cold winds, and with literally every single breath you take, it feels like your chest is just freezing from the inside out. Now, let's pause right there for a second. You're standing on the highest point on Earth, right? That means you are thousands of meters higher up in the sky. You are, quite literally, closer to the sun.
So what exactly is going on here? Let's dive right into this paradox. If we're closer to the sun, the ultimate giant heat source for our entire solar system, shouldn't we be warmer? Basic logic tells us that, hey, if you move closer to a fire, you're going to feel more heat, right? But the harsh, brutal reality of Mount Everest is that temperatures up there can absolutely plummet to a bone-chilling minus 60 degrees Celsius. How does that make any sense at all? Are we just completely wrong about how the sun actually warms us? Well, let's figure out exactly what's happening. To solve this little puzzle, we've got to completely unlearn a major childhood assumption. Section 1, Earth is the real heater. So, there is a really stark contrast between what we think happens and what actually happens out there. The big myth? That sunlight shines down and directly heats the air around us as it travels through the sky. Makes perfect sense, right? But the actual fact? The sun doesn't directly heat the air at all, not even a little bit. Instead, those solar rays travel completely uninterrupted through the atmosphere until they finally smack right into the Earth's surface, the dirt, the mountains, the oceans. Our planet essentially acts like a giant sponge, just soaking up all that incredible solar energy. And then, very slowly, the Earth radiates that heat back outwards, warming the air from the ground up. So, the absolute crucial takeaway here is this. The true heater that's keeping you warm right now, it isn't the sun up above you. It's the ground right beneath your feet. Okay, so if the ground is our heater, why doesn't climbing a massive mountain make us warmer? Well, that brings us to section 2, the illusion of scale. 150 million kilometers. That is the staggering, almost completely incomprehensible distance between the Earth and the sun. To put that massive number into perspective for you, light itself, the absolute fastest thing in the entire universe, takes over 8 whole minutes just to cross that gap. It is a vast, echoing void of space. And that brings us to the other side of this crazy equation, 8.8 kilometers. That is the towering, imposing height of Mount Everest. Now, to us tiny humans, an 8.8-kilometer vertical climb is a monumental, genuinely life-threatening achievement. But compared to 150 million kilometers, it's practically nothing. Seriously, thinking that climbing Everest gets you significantly closer to the sun's heat is exactly like standing on a dining room chair because you want to get closer to the moon. Technically, sure, yeah, you're slightly closer. Practically, it has absolutely zero impact on how much heat you're actually receiving from space. So we know the sun's distance isn't the real factor here. What is a factor is our distance from the Earth's surface, our giant planetary radiator we just talked about. And there's a very strict, undeniable mathematical reality to moving upwards. Scientists have measured that for roughly every 1,000 meters you climb away from sea level, the temperature drops by about 6.5 degrees Celsius. Think of it kind of like walking away from a roaring campfire on a really cold night. The further you step back from that base level, the colder it gets, simply because you're leaving the heat source behind. By the time you climb almost 9,000 meters to the peak of Everest, you have walked very, very far away from that campfire. But distance from the guard is really only half the story. Let's move on to section 3, the thin air effect. I absolutely love this analogy because it takes a kind of complex atmospheric concept and makes it so incredibly easy to grasp. Down at sea level, gravity is pulling air molecules tightly together. It's super dense down here. There are lots and lots of particles. And because it's so dense, it acts a lot like a thick, heavy winter coat, what we're going to call jacket mode. When the Earth radiates heat, this dense air traps it perfectly. But high up on a mountain, gravity's grip is just slightly weaker and the air pressure drops off significantly. Those air molecules are spread way, way out. It's thin. This right here is t-shirt mode. So even if the sun is shining incredibly brightly, that super thin air simply cannot hold on to the heat. It escapes instantly. A mountain is basically permanently stuck in t-shirt mode. And honestly, you've probably actually experienced this exact phenomenon yourself if you've ever flown in a commercial airplane. When you're cruising along at 35,000 feet, you are way, way higher up than Mount Everest. Right outside that little window next to you, the air is so utterly thin that the temperature is minus 60 degrees Celsius. It is a literal frozen wasteland out there. But inside the cabin, you're relaxing, maybe watching a movie, drinking a nice hot cup of coffee.
Why? Because that airplane cabin is artificially pressurized. The engineers are actively pumping air in to recreate those dense, thick particles we have down at sea level. They are literally forcing the cabin into jacket mode so you don't freeze to death. Pretty wild, right? So, we know that thin air means terrible heat retention. But what happens if we leave the Earth's atmosphere completely? Section 4. Surviving the space vacuum. To really understand space, we need a super quick physics refresher. There are 3 primary ways heat travels. First, there is conduction. That's heat moving through solid objects, like when you accidentally touch a hot pan. Ouch. Then there's convection, which is heat moving through fluids or gases. Think boiling water or warm air rising up to the ceiling in a room. But space? Space is a total vacuum. There is no air, there is literally no liquid. So conduction and convection simply fail. They cannot exist out there. And that leaves us with only number 3, radiation. This is heat traveling as pure electromagnetic waves, completely unsupported by any physical matter whatsoever. Now prepare to have your mind totally blown by what pure radiation actually looks like in a vacuum without our nice protective atmosphere. Because there's zero air up there to trap, distribute, or soften the heat, the International Space Station is at the absolute mercy of direct solar radiation. The side facing the sun, it absorbs those uninterrupted rays and literally cooks at a blistering 120 degrees Celsius. But step just a few feet away into the shadow of the station, with no air to carry that warmth around the corner, the temperature instantly crashes down to minus 150 degrees Celsius. From boiling fire to absolute ice in a matter of minutes, entirely dependent on exactly where the light hits. It is extreme. What an absolutely incredible journey, right? From a snowy mountain peak all the way to extreme orbit. Let's wrap this up with Section 5, Closer to the Truth. I want to leave you with this final thought today. Climbing a mountain doesn't bring us closer to the light. It brings us closer to the truth. You see, when we climb upwards, whether we're trudging up Everest or rocketing into orbit, we aren't getting closer to the sun in any way that actually matters. Instead, what we're really doing is just walking away from our planetary radiator. We're stripping off that thick protective jacket of our dense atmosphere and exposing ourselves to the harsh, raw reality of the universe. Sometimes, the truth is the exact opposite of what common sense tells us. So next time you look up at the sky, ask yourself, what other completely obvious truths around us are actually just illusions? Think